we sat there an hour and a half, one of the last times we met. We sat there an hour and a half in the city.
I'll go ahead. Yeah, I'll go ahead and start the Periscope. Maybe. There we go. All right, guys. So I think for the most part, most people have filtered in. There should be 5 or 6 more if they show up that have registered. So first off, I just want to thank you guys for coming out. We did one of these a few years ago out at Mooresville Library, and it seemed that people like it. And you know, if you come to one of these, you know it's probably going to be a lot of weather information. All right, so we got a lot of stuff. I got a ton of stuff to teach you and show you. That hopefully will help you as an enthusiast or as someone who is in this field and makes decisions based off snow and all that good stuff. So what I'll do is go through a couple of different seasonal forecasting methods, some short-term forecasting tips and tools for you. I'll give you some free resources and some websites you can visit to get data from, and then obviously I'll go over my winter outlook, the reasoning behind my winter outlook, and things like that. At any time along the way, ask questions. We are periscoping and YouTubing live, so people who didn't come in person can watch it from home or whatever, and they can tweet us questions as well. So if you see questions, throw them at me as we're going. And if we get halfway along the way and no one's asking questions, I'm going to stop and make someone ask a question. All right? So just make sure you come here. I want you to don't leave here without any questions or without any of your questions answered. Okay? So my name is Michael Clark. I'm a meteorologist. You guys know, most of you probably subscribe some way or another to BAM if you're here, I would imagine. Maybe some of you are thinking about it, whatever the case may be. There's 6 of us on staff. This is our office. Our office is across the hall. I'll take it to you and show it to you when we're done if you're interested in checking it out. So we put out forecasts, to primarily, we used to be a company where we were posting a lot of free stuff on like Facebook and Twitter and things like that. And now it's all private. Everything we do is a subscription base, or we try to keep what we post, the good stuff and the content, to people who are subscribers to the site. So it's a private business is what it is. If you have questions about anything as far as service or subscriptions or whatever, let me know going forward and we'll get into it. All right? So, seasonal forecasting. Big one this year. So has anyone ever heard of Weather Trends 360? Anybody ever heard of that company? So they what they do is they go out and they forecast weather 11 months out. All right? And they claim that they can forecast it down to the day. All right? So if we're sitting here right now, they say they know the forecast for April 11th, 2017. All right? It's pure hogwash. It really is. So what they do is they take all this mathematical data and they start making predictions. Well, the prediction this year was for a drought to be worse than 2012, widespread, terrible situation for farmers and record heat, all things of that nature. So what that does, whether you know it or not, is it actually completely changes the economy and the market. All right, people start buying things and selling things and doing things they don't need to do based off of predictions that far out. So when you tell the farming industry that you could have $7 corn per share, and I still don't think it's over 3.25. I'm not sure what it is, but it's a huge impact in the agricultural world. That is a multi-billion-dollar business. So seasonal forecasting it's not only is it risky, okay, because it does have it's not an exact science, but the job of a forecaster or a meteorologist is to inform you of those risks, is to tell you, here's what we see, but the risk of is this, it may not happen, all right? So I think it really comes down to an art, to some experience, and a little bit of science. Some people say it's a pure guess. I don't necessarily believe that, because I think if you do enough research, you can find what you really want to know when it comes down to seasonal forecasting. Some of the biggest things, in my opinion, are sea surface temperatures. We'll look at that as we go. Soil moisture, teleconnections. We have dynamical models, we have statistical models, we have analogs, and probably the most important thing is trends. So pattern recognition, just seeing what the pattern's doing, what it's been doing all season, what we think it's going to start to do as we get into the winter months. It's just picking up on things and thinking outside the box. All right. Another thing we do a lot of is organic forecasting. All right. And some of the founders of this, Joe Rankin, some guys that we've worked with for several years now, kind of trying to perfect different methods of forecasting the weather, where we look out into the western Pacific Ocean, into East Asia, where we try to find patterns that are occurring out there that will occur here as they get closer, all right, as time goes on. Southern Oscillation Index, some of you guys have watched the videos, I'm sure you hear about the Southern Oscillation Index when we see big swings in the index. That can be indications of big pattern changes. So like the heat we've had here to open up October, okay, it's been in the mid 80s. 20 days ago, we had a huge SOI rise around 20 points. All right, so we were able to, we told you about that about 25 days ago, that there would be heat to open up October. All right, the next thing we could tell you about is because after that rise, it fell back down, we see a big cold front the second week of October. It snowed in Minnesota 2 days ago, and it's in the 20s in the plains right now. All right, so the stuff works. No doubt about it. It's 47 in Indy right now, so we've finally gotten to an average point for the month of October. So really, guys, it's just a thinking outside the box approach. It's a common sense approach. You can take, all the meteorology, all the master's degrees, the PhDs, anything you want to do, and apply all these, things into a forecast. But at the end of the day, it comes down to common sense, thinking outside the box, and just making simple observations that can make a big difference. All right, we're going to get to fun stuff, I swear, after this little couple of lines here. So, short-term forecasting keys to success. The number one thing. So, if you're waiting for a snowstorm to come in or a severe weather outbreak to happen, or if you're terrified of storms, or whatever the case may be, whatever the reason you're a weather enthusiast or whatever you're watching, always recognizing the pattern is knowing what the pattern in Indiana typically does. For those of you that have lived here for 30, 40 years, you just know how the weather behaves. There's no other major big secret to that. That holds true. It's just what typically happens as we go throughout a storm. All right. Typically, do we get dry slotted during a snowstorm? Typically, show of hands. Yes. Yeah. Typically, there's always a dry slot we deal with. Okay. Whether the models want to say there is or not. There's a lull in there, and people are emailing me like, you suck. And then it snows 2 hours later. So it just always happens that way, all right? So, again, thinking outside the box, common sense approach. I know people without meteorology degrees that can forecast better than meteorologists can. Right? I know people that have no college background that could out-forecast a PhD student any day. Right? And it all comes down to, you just have to be able to apply the common sense to it. That's what we do. All right? Dynamics are crucial. All right? These 500 millibar maps we talk about, these SKU-T maps we talk about in our videos, knowing what these mean is so important, especially in the time of a snowstorm, any kind of storm whatsoever. And I'll show you how to read these maps. That's what I'm going to do. Okay? The number one thing is knowing the biases within the computers in these short-term events. Does anyone know what the GFS computer model, what its bias is? Anybody?
That progresses storms too quickly.
Too quickly? What else does it do? GFS has a couple of biases. It's too cool. It's often too cold. It's too fast. Okay? What about the European? Anybody know what its bias is? Anybody? It's too.
Snow codes in the long range.
It does that, but it's also too warm at the surface with its temperatures. Okay? Sometimes it just overdoes surface temperatures. What about the NAM model? You guys know the NAM? Anybody know what its bias is?
Too much precip.
Too much precip and
Got a northwest warm bias.
it's got a northwest bias, essentially where it takes the storms too far northwest. Okay, it just the model just has that problem. So it's knowing individual things like that as we go forward that will help you. So oftentimes if you're reading John or Kirk or whatever my discussions or forecasts, we're always going to refer to what's called 500 millibar vorticity. 500 vorticity, vort max, whatever you want to call it. Energy in the mid-levels. The most important thing to know about this as we're showing you this, and I'll show you again on a map what it looks like. Let's assume, okay, that the two, essentially a vorticity maximum is just an area of energy, lift. It's where you get precipitation, okay, where you can get snow, whatever, lift to generate clouds. What happens is, when you have vorticity that is aligned north to south, okay, the outcome of this, okay, is these typically tend to attract each other. Essentially, simply put, so this is the pattern. Remember when we had the big blizzard in 2014 in January, big cold, 12 inches of snow, whatever. This was the map prior to that, okay? And what we had is we had a piece of energy up here, and we had a piece of energy down here. And in wintertime, what you need these pieces of energy to do is to phase. You need them to come together and to kind of marry up, all right? And when you watch this chart on the models, this 500 millibar vorticity, what you're looking for is key pieces in upper levels of the atmosphere to see these phase. Well, if we go back to this graphic, we know that the north and south relationship, as these come together, typically what's going to happen is the southern max is faster. It's got more energy. It's where your moisture comes from, right? So you've got your Gulf of Mexico. Okay, your moisture's coming in from the south. This one tends to speed up a little bit. Well, what happens is, once this one starts to speed up, it's essentially going to pull this one in with it, and you get a phase. You get a big storm that develops. So you take the polar jet, and you take the subtropical jet, and you bring the two together, and then you have cold air and a lot of moisture. Okay? So as someone who's not experienced enough, if they looked at this map, they would say, yeah, we probably don't have a big storm coming. Someone who's probably forecasting the weather on a TV station or something, they're going to say, yeah, probably not. We got a chance of snow, but do we see a big one? Not yet. Well, it's because the models haven't advertised the phase yet, but if you know the pattern and you know how these work, you know that there will be a phase and that there will be a big storm system. Okay? So,
Michael, what is the criteria for how far out you can see that happen?
to see a phase in a storm system in a non-El Nino year, you can see them 7, 8, 9 days out. The problem is computer models have a bias in them to phase these systems because they typically do. So in an El Nino year, the southern stream, the southern pieces of energy are always faster and more amped up. They can't phase with the northern stream, which is why we don't get big snows, oftentimes in El Nino. So the computer in the 5 to 10 day range wants to marry these things up because statistically that's what they do. Does that make sense? To whereas in La Nina or a neutral pattern, that is not an issue. Okay? So I'd say, Gary, in this winter coming up, our lead time's probably going to be pretty good this year. We don't have any big wrenches in the pattern that are going to throw off how computer models typically behave. Last year was a nightmare with that, right? Notice last year, always by day 13, 15, there was always this cold blast coming that never came in the computers. It was always there. It never showed up. Okay? There's reason behind that. We'll get to it. So, vorticity, anytime we talk about that, what we're trying to show you is where the dynamics, where the true lift and the true energy is of a storm. If we see that vorticity coming into our area, despite what a future radar looks like or what the free AccuWeather app says or whatever, we know there's a big piece of energy coming. So vorticity is key in tracking these storms, okay, at mid-levels. So this might look very intimidating to you. It's really not, okay? This is a sounding or a SQT. Our job in the short term for you guys is we try to pin down as best we can what precipitation type will be, say, in a winter storm. All right? That's not easy to do. That's pretty tough to do. I want everyone to write down pivotalweather.com. I'm going to talk about them this whole time. It's PIVOTAL weather.com. Everything on that site is free. Okay? The soundings are free. The data's free, the maps are free. There's no subscription required. No. I don't know if it's going to continue that way. I would imagine eventually there'll be a paywall over that site, but there isn't yet. Now, so I'm going to just explain this to you. Very simply put, at the bottom of this graph, okay, and if it's hard for some of you to see, you can ask me afterwards. I'll explain this to you. This is a profile of the atmosphere from the ground all the way up to around 90,000 feet. All we're doing with this sounding, with this profile, is we're looking at the temperature. Okay? That's it. All right? The green line is dew point. The red line is air temperature. What happens when the dew point and the air temperature become the same? Yep, it condensates. You get moisture, right? So this here, the red and green line are touching all the way up. This is a fully saturated sounding. There is no dry air whatsoever that we would have to be concerned with in this sounding. Okay? This blue line right here that's denoted by 0 Celsius. 0 Celsius is 32 degrees Fahrenheit. Okay? This line tells me from the surface all the way up to about 25,000 feet what the temperature is. Okay? That's very important for determining precipitation type. All right? So you can see the red and the green line, they stay to the left of the 0 line the entire time. They never once cross over the above 0 line. Okay? Obviously I've put all snow on there, but this would be an all snow sounding. We would have no worry of some sleet mixing in, or it falls as rain, freezes on the surface. There's none of that concern here. Does everyone follow me with that? Okay? The next sounding is a bigger problem, right? So we still have a saturated sounding, no doubt about it. But air right around 4 to 5,000 feet above the surface has crossed over the blue line. Okay? So you have all this moisture, all this stuff falling, okay? It's falling as snow, comes down to around 4 to 5,000 feet, gets into a warm bubble of air, and it melts all of it. Well, because the warm layer of air is suspended to around 4 to 5,000 feet, once the precipitation starts falling and gets through the inversion here, goes back down, it has a chance to refreeze. So it turns into sleet. So sleet does two things. Completely ruins a snowfall forecast and robs moisture. Okay? Oftentimes, if there's a big storm coming in and there's a big area of low pressure coming in, if we start as rain and then we transition to sleet, sleet can cool the column of air and actually make the transition to snow faster. Okay? So sometimes if we, in a situation where we have a rain-snow line right at I-70, pretty much every year, okay, and we see that transition to sleet, oftentimes it will tell us snow's coming because we know cooler air is working in. But there's still a little warm layer right there. Does that make sense? I'll illustrate it for you. So essentially all this is the surface. This is as we go up into the atmosphere. We're about 2,000, 5,000, 10,000 feet. Okay? Here we are down here at the ground. All right? When we are completely cold, wet, left of the environmental temperature, okay? See my 0 line? The line is left of 0, so we are below 0. So the environmental temperature all the way up is below, it's an all snow forecast. Okay? What happens when we get a little bit of a warm layer, shallow warm layer, around 5,000 feet? Okay, we started as snow, we partially melted the snow because of the warm layer, and then the drops refreeze and they become sleet at the surface because there's a deep cold layer down at the surface. Right? Does that make sense? I hope you guys are following me here. When we get to pivotal weather, I'll show you how to find these. It's very easy. Okay? This is the number one biggest problem, and I believe from Paducah to Kentucky, southern Ohio, West Virginia, big ice storm problems this year. And we'll get to that, all right? I believe we're going to have a lot of problems with the ice storms, given the pattern that we're heading into this year. Not for us, right? But the problem here is the environmental temperature, what starts to happen, at the bottom though, we have a very shallow cold layer. So like right at the surface, it's 31, 32 degrees. So that's a freezing rain setup. So I just want you to visualize this because the idea of us being able to predict that is truly remarkable, really, at the end of the day, if you think about it. Right? Being able to take that parcel of air and all the way through the atmosphere and then drop it down and then be able to predict its temperature, that's pretty crazy. That's pretty wild. That's hard stuff to do. All right? Hey, Brian, we got some guys in the back. Maybe see if we can get them. You guys got the seats back there? So essentially what you want to be able to envision here, what I want you to know is how tough it is to nail down a precipitation type forecast. Oftentimes people, they get so frustrated because they were supposed to get 6 inches of snow and they got 2.5 or 3. I mean, you'd be surprised how mad people really do get. You know, if they're supposed to get 6 and they got 3. Now, understand if you're making a living off of it, I get it. It makes sense. But at the end of the day, you have to really understand, if you get a ruler out and you look at 3 inches, and you're able to predict that at a certain location, there's nothing short of a miracle from that. That's pretty remarkable. Okay? The issue that people have is they think that we can forecast all this stuff down to their backyard, down to their porch or their street. All right? That is not and never will be possible, ever. It's not possible. Even getting it down to the county takes some serious analysis and skill. Okay? And even if you have there were a couple times last year or 2 years ago, got some clients down in Bloomington where it just stayed colder. They got more snow than, we'd say 2 or 3 and they'd get 4 or 5 or 6 because the warm air never worked as far north as we thought it would. So those things happen, and you're never going to be able to get that perfect. But my point to this is, if I can show you how to find these warm layers, okay, and show you on this website how to use it, while you're at home, you're going to be able to say, oh, I know what Michael's next update's going to say. We got some warm air working in. We got some problems with this system, right? So this is a final graph to illustrate this. You've probably seen this several times throughout different winter seasons. Different meteorologists talking about how the layers of air affect different things. So again, this is the warm layer. Notice as we get into less warm air, okay, we get into an all snow profile. But as more warm air works in and the cold layer becomes more shallow, the problem becomes freezing rain. Any questions on that at all? You guys have any questions about how that works? Nope? Okay. All right, so moving forward to the pattern here, I have used this graphic. Every time I talk, I will always show these and explain myself because this works, I'm telling you. So we look to the Western Pacific Ocean for certain patterns. Okay? We look for big storms that we can call 3 weeks out ahead of time. All right? Most of the time, we do pretty well. All right? I would say 8 out of 10, 7 out of 10 times. There's always going to be those times where it just doesn't pan out. But it's cool to be able to see them that far out, right? 17 to 21 days. It's pretty neat. So it's funny because you can look at the other big dogs in the weather world, and you can see where they're getting their information from. You know, you can see where they're forecasting, you know, what the computers are saying. It's very simple to point that out. So, simply put, this big old complicated graph, all it means, all it's telling us is where temperatures are above or below normal in Indianapolis over a 15-day period. The days are down here at the bottom. So what we do is we look to the western Pacific Ocean. I'll go back to that graph in a second. Anyone can do this, but for some reason no one does. All right? Anyone can use this method. It's not like you're going to get in trouble if you use it, I promise. All right? Essentially what we do is we take the United States, all right, and we found reference points, and we overlay it into East Asia, and then we overlay it into the Bering Sea of Alaska. The patterns that show up here reoccur and show back up in the United States in certain time frames. It's that simple. So if I see a cold front in East Asia on the 8th, today's the 8th, there's a cold front coming through the Korean Islands in Asia. The correlation is 6 to 10 days later in the United States, there will be a front that comes through. Now, will that front be in the Dakotas or in Indiana? I don't know. Can't tell you. There will be a front. It's just like this one that's coming through right now. We talked about it 3 weeks ago, but 3 weeks ago we wouldn't have been able to tell you that the coldest air would be in the plains, not in the Ohio Valley. Okay? See how these cold blasts have worked the last 30 days? They start in the plains and then the cold kind of lets up in the east out as it moves east. The reason for that is the southeast ridge, and we'll get to that. But at the end of the day, what's funny, what's down here? What's this? Anybody tell me what this is? Who said it? Ridge. Kirk said it. That's not fair. No, I'm just kidding. So there's a ridge down here, all right? So there's a ridge in the United States, but there's a ridge in the Western Pacific. Is it a coincidence, or is there actually a connection? Right? This ridge has been here for 90 freaking days. It's not going anywhere, I'll tell you that right now. This is going to be a problem this winter. Right? So, in the Bering Sea, the next thing we can do, this is my fancy painting skills, is look at bigger storms in the 17 to 21 day range. So East Asia is 6 to 10, BSR is 17 to 21. For about 2 weeks now, we've had our eyes on some huge cold fronts in the Bering Sea. They've really been remarkable, the size that they've been. We really think there's good potential for some pretty big storm systems the end of October. Some indications could be that it would be a cut-off upper level low again. Those aren't any fun. Can't help you. We don't make the weather, we just forecast it. But there is indications that a big system will be there towards the end of the month around the 25th. There's even more indications that there could be a front there again around the 28th and then around the 31st. So it's been pretty common the last few years we've had some big Halloween systems, right? If we go back to this, the red line, so in the European model or the GFS, so the way this works is all these models, they have ensemble members. They have a number of different, all an ensemble is it takes the computer and it initializes it slightly different to give you a different outcome or a different option as a forecaster to use. Okay, so if someone says the ensemble mean, they're taking the average of all those ensembles and the mean comes out. The European has 51, the GFS has 21. Right? The European literally has dominated the last couple of weeks with this pattern. It failed miserably on the hurricane, but so did every other model. Okay? So, what we see here, note how we have a real tight look in the 5 day range. Not a lot of question here in the forecast in the short term. How many of you guys watch my videos? Can you give me a show of hands so I know that you guys, okay, perfect. So most of you know this map. All this is, again, is a temperature series over a 15-day period that will tell you normal or not normal. That's it. Type consistency here. Well, look at the individual ensembles that sniffed out the cooler weather for this weekend. Look where we are now, right? We had some members that were still pretty warm above normal. But overall, for the most part, we knew that a front was coming, and we knew there would be a cool down, all right, based off of what we saw in the Western Pacific Ocean. The next one we target is around the 14th through the 16th. We have members that are very cold in that time frame, but we also have the ensemble mean, the high res data, and most of the ensemble members above normal. So that puts us in a tiff, like, well, do we tell you that it's going to get cold, even though everything says it's not going to? So we figured it out now. If you watched the video yesterday, now what we know is that we're going to have cold fronts, but we rebound quickly. Okay? And that's the La Nina type. That's the La Nina drive of this atmosphere. La Nina is in control right now. We'll get into that. But we can sniff out these fronts. There will be fronts. And then each front will progressively get colder, obviously, as we go further. Okay? Any questions on that methodology or that idea? It's really a very simple approach. You're really shocked that it's not used more than it is, but it's just not. So.
Can I ask you that ridge? Does that also mean it's dead calm in the South Pacific or in the Western Pacific? In terms of traffic, in terms of shipping traffic and stuff like that?
No, essentially, actually, this can act as a steering current and direct typhoons around the periphery of the ridge. So if we get a typhoon that develops here around 160 east, that ridge would steer it up into Asia and pull it back east. So that's where we get our recurves from our typhoons. I actually like to see that there. Because when we see that recurve from the typhoon, that gives us that cold front 6 to 10 days later. Does that make sense? Yeah. So it acts as just a steering current, really. All right? Great question. This looks complicated. It's not. I'll explain this to you. What this is computer model verification scores. And the question we ask ourselves is, are they that good? Are computer models really what we think they are? Right? Do we really think they're as good as what they're talked about? So this is the fault pattern. Got this graphic here from a great Twitter follow, Ben Knoll Weather. He's on Twitter, Ben Knoll. And he posted this graphic a few weeks ago, a week ago. And it caught my eye because I thought, oh, this is interesting. It tells us that, some of the worst performing computer models in the country or in the world are the American models. They're terrible, right? But the best computer model out there is the European, okay? Essentially put, it's the best, right? Some of these other models, like the 0Z Canadian, it's one of the worst models as far as sea level pressure is concerned, forecasting pressure at the surface 5 days out. It's the worst model you can look at to do that with, in terms of relation to fall. Here's another neat one. So this is over the past year. Simply put, the number one model at all the way from day 1 to day 15 is the European model. The skill scores are the highest. It consistently outranks all the other models, no question about it. All the way out from 1 to 15. What's the 4th worst model on the planet? The GFS. Okay? Out by day 13, 14, and 15, the GFS actually is deemed useless. It is actually not recommended to even look at it in that time frame. Okay? The scores are negative. The verification scores are negative. All right? So, what's the worst model in the world? The UK Met. The UK. And everybody seems to love that thing. I'll tell you right now, it'll bite you in the butt. Watch that model. Another model, we just talked about the Canadian. Now, if you look at the ensembles of the Canadian. It's the second best model in the planet. Anybody heard of Tropical Tidbits? TropicalTidbits.com. Okay, it's a free site. Free computer models. You get all the ensembles there that you want. TropicalTidbits.com. All right? It doesn't cost you any money. You can get all kinds of good data there. All right? And look at these different maps. If you watch my videos, I'm sure by now you probably know how to look at the 500 maps and see what the differences are. Yes?
Along with those models, does it have anything to do with the horsepower of the technology they're using to build all that? Because I thought the Europeans were so far ahead in horsepower, and Americans just bought a Cray not too long ago. Will that improve the American model?
Personally, I don't believe it will. So you can have a huge supercomputer that processes really, really fast. Actually, the GFS model processes faster than the European. It completes way quicker. The physics and the physics package and the ideas that go into the model are what make it. So even if we buy a supercomputer model or a supercomputer to run the model, it won't have any effect on the accuracy of it. So for example, Oklahoma University has a supercomputer. They run the GFS and they get it 18 minutes earlier than any other source in the world does. They charge $500,000 a year for people to access that for 18 minutes. It's the same model, just faster. Does that make sense? It's a good question. The computing power is great to have a model that will come out quick, but it will not help the accuracy of the computer. All right, the GFS is probably, I don't know, $20-25 million behind the European. And it's money that the government will probably never, I know they say they will, I don't know if they ever will. So it's probably 5 or 6 years behind the technology of the European. It's a good question. So those are just some of the things, like the ideas in my head as far as a forecaster, and some things I'd like for you guys to look for when you're watching the videos. Again, please feel free to ask me afterwards. I'm here, Kirk's here, John's here. You can ask any one of us if you have any kind of questions about forecasting, if you're looking at it yourself, trying to teach yourself, more than happy to help. So next, what I want to discuss is the winter weather outlook. Our ideas behind the upcoming winter. We've put a ton of research into this. We've been working on it for months. All right, we've literally digged up and unturned every stone that we can to get the best idea possible. So I'll share this probably next week with the clients on the site who didn't attend today. So you guys get it a week early. All right. So the idea, these are our analog years. Essentially, we take years that are similar to the year coming up, and we take all the data, pull it all out, and we try to find what the common theme is, what the setup is, what the idea is to the upcoming winter. That's what we try to do, right? So, none of you are probably going to remember anything from 60s or earlier. Does anyone remember winter of 81, 82, or 83, 84? Anybody remember those winters?
Is that when we had our blizzard? 72, right?
78.
Okay.
78, yeah. 85, 86, there was a blizzard night. 85, 86. 92, 93, 95, 96, that was the winter where the coldest temperature ever in the state of Indiana came down to Whiteland. We had an air temperature of minus 26 degrees. Okay? That's the polar vortex. All right, that's what that is. 2014, yeah, okay, it was cold. It wasn't minus 26 at the surface. The wind chill was. The temperature wasn't. Okay? 2005, 2006, and 2013, 2014. Okay? Essentially, a lot of the research we've done leads us to believe a big hitter winter is in the cards. Okay? Are there wrenches in things that could eliminate that? Absolutely. There are things that we have to watch, the trends and things and I'll talk about those. Simply put, this is temperatures from November 1st to March 31st, taking all these years and averaging them out. The average temperature is 32 degrees from November 1 to March 31st. That's the average temperature when you take the nighttime low, the daytime high, you average it out over that time frame. Okay? Simply put, I'm sorry, I explained that wrong, didn't I? My apologies, guys. The average is 35.5, not 32. Okay? Our analogs averaged out 32. The average is 35. Okay? What this does is, this blue line tells us each year, compared to the average, which is the orange line, where temperatures were from November 1 to March 31st. So every analog year shows temperatures ran significantly below normal for that entire time frame. Okay? Now, you're thinking, who cares if it's 35 or 32? Well, that's huge in terms of 6-month span. That's significantly colder. Okay? That's mornings in the single digits and below zero. That's cold weather. When you start getting departures of 1, 2, or 3 below a month, 2, 3, 4 months out, that's significant cold. Okay? Everybody's always like, well, you say 1 degree below normal. Who's going to know that? You'll know. All right? You'll feel it. This is average temperature from January 1st to March 31st. The normal is 34. The idea behind this is it's a backloaded winter. A lot of cold still available in March in these analogs. Okay? Still looking at snowstorm potential in March. Still looking at cold air potential in March. That's the point of this graphic. Okay? The average 32, or the average of my years is 32, the normal 34. So you're running about 2 degrees below normal. The trend here is pretty much it's below the orange line for the most part, except for 05-6. 13, 14, remember we had plenty of snow in March of 14. Okay, we were still hitting it hard in March of 14. Okay? This is average snowfall in Indy from November 1st to March 31st using our analogs. Okay? The average snow, okay, the normal snow is 25.3, which is the orange line. This is where we run normally for this time of year, or for these analogs from November 1 to March 31. We average 25.3 inches of snow, first flake to last flake. That average has actually gone down a couple tenths over the last few winters. Okay? The analogs suggest that the average overall suggests 35 inches of snow this year from November 1 to March 31, which is 10 inches above average. Pretty significant for Indiana. Okay? There are a couple of winters in here that were below, back into the 50s. Okay, there was 85, 86. We only had we had like 2 big storms that year. All right? And the rest were above the normal. Obviously 13 and 14. But our 3 biggest winters ever in Indy are some of our top analogs this year. I'm talking 50 inches plus. All right? Those are some of our analogs. So that's got to be exciting. How can you not get excited about that? Come on. All right, so average snowfall for Indy. This is if we take the idea of just La Nina. We don't look at anything else at all. We don't look at the PDO, the NAO, any of that other junk. We just look at the La Nina, ENSO. Okay, this is what typically happens in Indy for snowfall. The normal, 25.3. The average out through all of the years comes out to 26.6. There are some years in here that are big hitters. There are some years that are not. Okay? Point is, with a La Nina, it's going to be cold somewhere. There's no way that the whole country will be like it was last year. It's just impossible. The El Nino is a product of warmth. La Nina is the opposite. Okay? Typically, La Ninas in the Ohio Valley are good winters. But considering you like snow. If you don't like it, then it may not be a good winter for you. All right? Last fancy graph, and we'll get into, Kirk made these graphs, by the way. He did a great job. So, the average temperature for Indy from January 1 to March 31 during La Ninas Here's the average, the orange line. Here's where we ended up. Okay, for the most part, below normal. Right? Except for 01, 02. For the most part, the signals continue to indicate cold. Okay? So, when we talk about, at the beginning of the show, we talked about sea surface temperature analogs. I'm a firm believer this is single-handedly the most important thing in forecasting seasons out, is the ocean temperatures across the globe. This is the current setup right now. This is the sea surface temperature anomaly map right now. Just grab that this morning. All right, equatorial Pacific right here, or equatorial, the equator right here, the equatorial Pacific right here. What does this look? Does anybody know what this looks like?
Oh,
Yeah. What signal is this? Exactly.
Kind of looks like a Modokai.
It could, but the issue now is, Dustin, is that we're seeing a lot of cooler water pop up in regions 1 and 2, regions 3. So it's broken down into regions. You have 1 and 2, 3, 3.4, and region 4. Yeah.
So if the coldest waters were in regions 3 and 4 to the east, I know with El Nino, that would have been a ridge in the east. Now would that mean a trough in the east?
The way it works is, if the coldest waters statistically are here, which is regions 4 and 3.4, the direct response is a ridge in the south.
Region south.
Okay? Especially with warm Gulf and Atlantic waters. The analogs in the research suggest this setup here would promote a southeast ridge this winter. Okay? Which means there will be a battle zone. There will be temperature problems in storms, depending where these storms can set up. No doubt about that. All right? But look at this warm layer of air. It's been referred to as, was it Godzilla or something? Is that what it was? Last year it was Godzilla versus El Nino or something ridiculous. And this is a blob. This is known as the PDO. Well, technically now, guys, the PDO has slipped into a negative state, but we still have a huge blob of warm water here. That should promote an area of high pressure. The direct result from that should be some heights, upper level heights that expand. The direct result in synoptic meteorology, so when you say synoptic, it's Greek for large scale, big, just means big. So in big meteorology, all right, in the grand scheme of things, where there's a ridge, there's a trough. No matter how, it's just 101, it's physics, it's the law. There's a ridge here, the direct response is going to be a trough. Okay? That's why it's so important to see what's going on in the Gulf of Alaska. Like right now, we have a big low out there, a big Aleutian low. Okay? There's a ridge that's popped up just east of that low, and we're cold right now. Right? It's all about the location of where these are at, though. It's a little bit further west than what it has been in years past. It leads me to believe the core of the coldest air this winter and the storm track will be pulled further west into the Ohio Valley and the northern plains. Okay? That's the methodology behind that. If this blob was a little bit further east, say up near the coast, then we'd shift the low and the colder air further into the east and northeast, into the interior northeast. Okay?
That's kind of why we got clippered so much a couple of years ago, wasn't it? Because everything was shifted east.
Yeah, exactly. And this year we could actually get both. It could set up to be both, and I'll explain that. All right? But what's key about this setup is Dustin asked, with this setup here and the warm waters here, the common denominator, the common theme is a ridge in the southeast. We've had the ridge for 90 days. It has literally aged me, okay, in the office. Kirk and I will sit there every week, discuss it with John, and it's like, it says it's going to go, but it never does. It's just not going to go anywhere. And with this look, it's going to be a problem this winter for those in the Tennessee Valley, in the tri-state area. I do believe that. Another big thing we've been watching, and I'm not going to go in a lot to what this means, because it's still largely understood. It's very complex, but it's known as the QBO. All you need to know is that a a negative QBO, all right, which suggests, or I'm sorry, a negative QBO or positive QBO would suggest a lack of blocking. As the QBO starts to slip down into the negative, then it starts to suggest that we could have blocking. If it's positive, no blocking. So I'm talking about your NAO, your Big Ridge in Greenland. Okay. Did you guys know in 2014 in that winter we literally had no high latitude blocking at all? We didn't have a Greenland block. We didn't have a nothing. All right. You would have never thought we would have had the winter that we had that year. Simply put, the trend is right now, the trend is favoring in the QBO high latitude blocking is possible in the latest update here, which would mean a big east base negative or big block east of Greenland. Essentially, that means the Northeast could have a big winter along with us. It really could just be a big winter. It could be. Look at the latest trends from the European ensembles in the NAO forecast. Negative the whole way through. A negative NAO is a block in Greenland. It's an area of high pressure in Greenland. The negative NAO, guys, all it does, all you need to know is when a storm system comes through, this is why I drew this back up like this. You get a high pressure system in Greenland. When the storms come through, they get blocked up and jammed up. And they come back around. Okay? And they just come up here and your pattern gets locked into place. You no longer have a pattern that things come and go. Things get there and they stay there, like cold air. Right? I've always said that if they're wearing shorts in Greenland, we're wearing winter coats in the Ohio Valley, in the United States. If it's warm there, it's colder here. Okay? We don't need a negative NAO for a good winter. It's fact. We don't need it. But I won't turn it down if it wants to show up. It'll take that sustained cold idea and really kind of up the ante. Okay? So this is the looks from the positive QBO. These are years where 92, 93, 13, 14, 85, 86. These are some of the years where we've had that positive QBO. All right? These are made from a good friend of mine, Ed Valley. Okay? Great Twitter follow on Twitter, at Valley Weather. Okay? His methodology is taking years where we have La Nina and a positive QBO, and this is what you would get for temperatures below normal. 13, 14. Okay? 53 inches of snow in the Ohio Valley. But look at where the core of the cold is associated from December to February. Okay? It's a blanket cold block here in the central portion of the United States. Look as you go January to March in the same years. This is where the idea of the backloaded winter comes into play. The core of the cold, minus 2 to 3 degree departures here if the QBO stays positive and we're in a La Nina. Okay? Huge signal for cold in the Ohio Valley, no doubt about it. Precipitation anomalies, anything that's green or blue indicates above normal precipitation. Look at this. What in the world do you think this thing is?
Southeast.
Yeah. It's in the analogs, it's in the data. It haunts you in your sleep. It's everywhere you go, that thing. I'm telling you. It's a nightmare. All right? But it's there. I mean, this is already happening right now. There's already a drought in the southeast. And the analogs continue to indicate that. And the pattern, you get a battle zone set up in here. You really do. Okay? You can have storms on the east side of the ridge, storms here on the north side of the ridge. So you got Gulf air coming in around the ridge. You got cold air coming in from the north. You phase these two. You get big hitters here. You get big snowstorms. Okay? Yeah.
I kind of noticed in Florida, in southern Georgia, and South Carolina, it's above. Would that lead to believe maybe more tropical development?
That's it, yeah. Anytime there's a ridge, guys, the signal of a ridge in the southeast, La Nina, it's a signal for hurricanes. You know, we've had more hurricanes now than we had in the last 10 years this year. All right? We got Matthew, Nicole. We got another disturbance behind that one. You know, they may not directly be impacting the United States, but the idea is there. And that's the thing to remember, guys, is these are ideas. Okay? This is not me saying, I guarantee you this is what happens. It's just the idea behind it. It's what goes into the winter outlook. a negative QBO, so we start getting the blocking to set up. The big negative NAO, the high pressure system in Greenland. What starts to happen? Okay? Cold starts to become concentrated in the Ohio Valley and the interior Northeast. Alright? Difference. That's the difference. Just get the high latitude blocking. The next way of taking and looking at a seasonal forecast is taking our sea surface temperatures and literally just matching them up to previous years. That's it. Just looking to the naked eye and saying, what year looks like this year, right? If I do that, here's the years that I get. 95, 96, 2000, 2001, I get 3 and 4, 5 and 6, 7 and 8, 13, 14, 14, 15. The average of that, looking at those sea surface temperatures, here's the cold. Okay? -1 to -2 from normal, from December to February. Look at January to March, same thing. Still running colder than normal. Look at the warmth down to the south. Look in Florida. Okay? Gets a ridging down there. Right? This is taking into consideration, we just get a La Nina, we don't look at anything else, we just slip into a La Nina. This is December to February. We run normal to slightly below. The second here is probably a ½ degree below in this area. Core of the cold in the northern plains. You take it January to March, the cold covers most of the country and you're below normal. That's just thinking we're in a La Nina. So essentially what I'm doing here for you is I'm trying to find how we could become warm, and I can't find it. I'm trying to find how this winter would turn out to be a warm, snowless winter. Okay? Because I want to be able to tell you it could be warm, right? I don't have anything supporting that. You look at the storm track in a La Nina year, it's right through the Ohio Valley. Goes right through. I mean, it's bullseye. That's really what it is. So I'm going to show you a couple of the seasonal models that have come in. And before I get to those, I want to tell you about how terrible they are. Okay? This, I did some research here last week. I know these are hard to see. But I put the grade next to it so you can essentially just understand that they're terrible. All right? October 11, October 12, October 13, 14, 15. Essentially what I've done is I went back the last 5 years and I looked at the seasonal models and I looked at their forecast in October to see how they did for the upcoming winter. Essentially I found that they're terrible and they have a horrible warm bias. They always predict it's going to be warm. Anybody see the Weather Channel outlook? Weather.com? Whole country torched. Not necessarily torched, but above normal. Except for the Northeast. What do you know? Isn't that funny? So, bottom line is, 2 very cold winters were forecast to be 2 very warm winters by the model that's commonly used by a lot of the bigger outlets. Okay. New European came in today. This morning it came in at 8 o'clock. I was in my office pressing the refresh button, trying to get it in so I can show it to you guys. This is for December. What do we have up here? What is this? What?
Negative BPM.
Ridge. We have a ridge. Just like I just discussed in that prior look. Look at the result. Look at the heights. Normal to below normal heights from the Ohio Valley east into the Northeast. This is a pretty darn cold look for December, guys, in the European. Okay? No doubt about it. Take it out into January. What do we have? What do we have? Here's Greenland. What do we have here? What? Block. Perfect. Okay? Look at the orientation of the heights here. Anybody want to guess what this is?
Clippers.
What's this?
You got a big trough in there.
Exactly.
Yeah.
Yeah, where there's a ridge, there's a trough. This is a cold signal. You got a cross-polar flow that's obvious as the day is long. Here, look at this. Connection to the Arctic air all the way up through here. These systems come down in from the north, They phase to the south. You get a big system here in the Ohio Valley, rides in the interior northeast, runs into the negative NAO, the block, and just sits there. And then probably what happens is that same storm system sits over the record warmth water of the Great Lakes, and you get tons of lake effect snow. Okay? It's all related. It's all connected here. That's an active look in January, I'll tell you that right now. And for the European to be advertising that, it's pretty darn encouraging. It's the best model in the world. This is the February outlook. Note what starts to happen, guys. The ridging is still here, still have a lot of high latitude blocking, no doubt. But look back up here to the west. We're seeing a little bit of a trough now. Okay? I do believe that a lot of the activity could start to move east later on in the winter, because now we're getting a trough, which means we're going to get a ridge, which means we're going to get a trough in the northeast. Does that make sense? So, but I still think we're in it out into that time frame. I still think we got a game here. All right. This is the Hugh-Vin dual model. This is what this model does. Is it essentially takes, and I know it may be hard for you to see. The U.S. is right here. This model takes sea surface temperatures, really kind of gives us an idea or a trend of where we'll go. This is December, January, February. It's warm, isn't it? It's a warm look. Look what happens January, February, March. Cold air just spills in. So, we have conflicting signals. We have some models that say December could be warm. All right? We've been very warm. I think we'll continue to be warm for the next few weeks. A game changer, I think, personally, a game changer comes in December. Okay? That's the idea. I know some of the models don't say that. The analogs support December could be cold and snowy as early in the Ohio Valley. Okay, our organic methods suggest a lot of snow in December. Okay, write one date down. I'd write the date of around the 28th of December down. I think there'll be a big storm in that time frame. Okay, the 28th of December, big storm, a lot of snow, possible. All right, if I get it right, tweet me. If I get it wrong, you'll probably tweet me. So, but here's the idea: the backloaded winter continues to show up in the models. This is the precipitation forecast. Look at the maximum showing up over the Ohio Valley. You get some dry signals up to the north because of the cold is probably so brutal in the northern plains this year. There will be some dry air problems, but you'll get clippers. But the above normal snowfall doesn't necessarily mean above normal precipitation. Okay? It takes 1 inch of rain to generate 10 inches of snow. Understand? So we could have 30 inches of snow, but run below normal in precipitation. Okay? So just because if you see a precip forecast from the CPC or the Weather Channel or anybody else, just because if it may say below normal precip, that doesn't mean below normal snow. That's a common misconception here, in my opinion. All right? We can even see forecasts where we run a ½ degree above normal in the Ohio Valley. Does that mean we're not going to get snow? No. ½ degree above normal is still going to be a cold winter. So even if you see above normal forecasts in the Ohio Valley, that doesn't mean it'll be an eventless winter. This is the NMME, the multi-model ensemble. So it takes in all kinds of different models. Here's what I've found. I've used this model pretty heavily the last 6 months. It did pretty well overall for June, July, August in precipitation. It did pretty good. All right? It didn't do too great with temperatures. That's the model where I showed you right here that its temperature forecast is terrible. I have found its precipitation personally to be somewhat useful. That's all I'm going to leave it at, okay? This is its precipitation idea for December, January, February. Above normal in the Ohio Valley into the interior northeast. Look what's down here. There it is again. There's that southeast ridge. I almost put that Terminator face from the Hurricane Matthew that showed up down here, because that's how big of a pain this has been. By the way, guys, almost 1,000 people have been killed from Hurricane Matthew. Okay? 1,000 people. If you see anyone on Twitter or on Facebook or anywhere talk about how these forecasts were hyped up and no one knew what they were talking about, those people are, you know what? That's not cool. That's all I'll leave that at. A lot of people lost their lives in this storm. This was a big deal. All right? So I don't know how you can hype up a storm where 1,000 people were killed.
Still got millions here in the United States with no power.
Yep.
So it wasn't
Exactly. So if you're following people, and this is way off subject, if you're following people on Twitter, Facebook, Instagram, whatever, and you're getting your weather information from people who are always downplaying things and telling everyone else nothing's going to happen and it's hype, unfollow those people. Okay? When crap hits the fan, what do you think they're going to be telling you?
We were right the whole time.
They're ridiculous. All right? But look at this. January, February, March, the signal increases. Okay? Over the Ohio Valley. That's actually a pretty significant signal this far out for an active storm track in the Ohio Valley. This just updated yesterday evening. I was texting my buddy Ed, if he's watching, I was texting him, hey, look at the new NME, blah, blah, however you say it, came in. And look what's here still, look at that. So an active storm track is still showing up in that data. And like I said, it did do very well over the summer. It really did. This is the Canadian for December. Okay? The common theme, big ridge, trough in the further west, probably not all that great for the east, probably some high pressure here in the area, but it supports the idea of winter coming on hard in December. I posted some analogs a few weeks ago back on Instagram about this, about how this December was lining up to, you might remember that year? I don't remember the year. A snowy December. This looks very similar to December of 2013. That was the year. 9 inches of snow in 13. Okay? Not a lot of high latitude blocking up near Greenland, but again, we don't need that here. These guys need it out in the east and the northeast. Okay. This is a snowy look. This is the January look for it. Okay? Look what the Canadian does. This may be a wrench you're looking for. It keeps low pressure here. Doesn't really develop much of a ridge. Got a west-based NAO, which means let's explain this to you. The ridge is west of Greenland instead of east. Not good for the east. Not good for the eastern United States. It'll push that storm off the coast. You'll never get it. And the cold air will never be there. There'll be a lot of clippers though. Okay. So an idea that if the Canadian is correct with its 500 millibar heights is that the cold would be confined back farther to the northern plains and the east would be warmer. This is a method that we've been having some fun with. This is off of the organicforecasting.com site. You can go there, it's free. That's where the Bering Sea rule is, the East Asia rule, and all that stuff's there. What this is the Rossby Reoccurring Wave Train, RRWT. Sometimes you'll see me hashtag that. Essentially what this method is it takes what's ongoing in the pattern and takes it as a reoccurring cycle, as a reoccurring pattern. Pattern recognition. Does that make sense? It's just a reoccurring pattern. Okay? Over the last 5 days, the average has been Indy somewhere around 46 inches of snow this year. That would put us in the top 5 snowiest ever. Okay? Could this be 150% wrong? You betcha. Could be. It's an interesting trend that lines up with the other analogs and the other data. What's neat about this is the run this morning, which is where this comes from. Big snowstorm right before Christmas. Big snowstorm on the 28th. Snow basically every day in January, and then a couple of snows in February. Okay? The run today, 58 inches of snow for winter. So, all right, take it with a grain. Don't leave here telling your friends.
I'm gonna go low to buy snow over at
Michael from BAM said 60 inches of snow this year. No, that's not what I'm saying. I went to lunch with a friend the other day, and he's back there, Brian Fields, and he said that people were talking about we were calling for snow in October. So I've never said that, but it's funny how rumors get going. All right, so officially, this is our official call for winter. All right, this is where we'll put my put my money where my mouth is, or my mouth where my money is, or however you say that saying. But the sustained cold is confined into the northern plains, Ohio Valley, and the interior Northeast. That's my opinion. Some of the guys at AccuWeather, they're a little bit further west, but they still have a core of really cold air that reaches into the Ohio Valley. Okay, they have a great winter outlook over there. Check it out. All right, weather belt. Joe Bastardi looks about like this, pretty close in the second half of winter to this look. Okay, this is January, February, March. All right, but overall, you see the idea. Overall, is cold really spreads in as we get to late winter. We got a -3 departure here. Sustained cold. I just don't know if I see a winter where we have a lot of warmth available. When the La Nina or when the Enzo is negative, or the La Nina is there, okay, you don't have a lot of sustained warmth to work with, given the pattern that sets up that I've showed you. Okay. Now, guys, it's October 8th. The pattern is starting to emerge. It's starting to show itself. The NAO going negative is pretty key right now. That's pretty cool, because the last couple winters we just haven't had a negative NAO. So we're starting to see perhaps some of that emerge. All right. This is my precipitation outlook. I do believe there will be 2 storm tracks that will be dominant this year. Here's the dry southeast, the active storm track going right through this area. I could have gotten fancy and made a pink or purple bubble here for ice, but I didn't. But I do think that would be a problem. Okay? But overall, I think early on, this is the early pattern, November, December, January. Early on, your snow is up here. This is track number 1. This is early on. A couple of clippers. There could be a 3 or 5 incher in there, all right? Early on, that's the idea. January, February, March, the idea becomes the active storm track in the Ohio Valley up into the northeast. Okay? You can see we're running an inch above normal in precipitation. All right? I was going to make a map that would show you above normal snowfall, or the snowfall percentage for the whole year, but I didn't, because it's still too early for me to make that map, in my opinion. All right? I'll make that map in November, and I'll show it to you in the emails and the videos. Okay? At the end of the day, guys, everything I've looked at, and I've really spent my team, we've spent a lot of time on this. And this is how we feel this winter will pan out. Yes, there's a potential that there's some kind of wrench involved. All right? The confidence, I would say, on a scale of 1 to 10 right now, is about a 7, that we have a pretty darn good winter in terms of cold and snow. Okay? So, that's the idea from that. What I'm going to do this for about another 10 minutes. I know you guys may be getting shaky a little bit. I want to show you real quick a couple of things on the website that are new this coming winter. All right? And just a couple other things on Pivotal Weather that I told you I would show you for you to be able to look at those things as we go forward. All right? If you have questions as I go through this, ask the questions. If you have questions at the end, ask the questions. If you're someone who's doing commercial snow removal and you have questions about service, ask me at the end. Okay? I would love to talk to you. All right? So I'm going to show you a couple things about our site, just real quick. Okay? So let me pull that up real quick for you. So this is our site, bamweather.com. Obviously, you guys all know that. Okay? I'm sure most. Is there anyone in here who's not a BAM client? Any? Show me. Perfect. I'm glad you guys are here. Yeah. No, so on our site, guys, for those of you that aren't clients, I'll show you real quick. What we do is we post the daily forecast. The zone forecast discussions are key in the wintertime. All right? This is where we post all of our thinking. All right? I believe, Kirk, did you send sent an update today. Okay, you can go here and we look at the discussion. You know, it's loaded with information. Where we're going, where we've been, what the forecast is. We highlight areas of concern. You know, you just get a lot of really good information. You get confidence and risks. There's a lot of good stuff associated with that towards the end. Another thing we've added this year, a couple things, are now the long-range outlooks. So these are custom-built, handmade by us, and we update these all the time. They're similar to kind of what you'd see with the CPC, if you go to NOAA, whatever. But so we apply a lot of our thinking behind that, a lot of our organic methods behind that, okay? We highlight dates of when fronts are going to come through, okay? We talk about the 30-day outlooks, the 90-day outlooks, and the winter outlooks, the 180-day outlooks. These maps are updated as frequently as needed, okay? Let me be very clear. If a forecast model runs 4 times a day, like the GFS does, that doesn't mean our forecast changes 4 times a day, okay? That's why we issue one update a day and a short term in the afternoon. We don't sit there and change it every single time you pull up your forecast, all right? That could be good or it could be bad, I don't know. And then we have the 15-day discussions that Jonathan does, okay? Loaded with information. Talks about East Asia. Look at that, cold front around the 15th, all right? So great stuff in there. Then we have the 30-day outlooks. We have tropical analysis that's done by Kirk. Okay, you can get on the site and find these. I've had a lot of people ask me, what about the app? We don't use the app anymore. You go to the browser on your phone, you type in bamwx.com, make it a home icon on your phone. It's the same thing. Literally all the app did was pull data in and from the site and make it an app. There's no difference. We will have an app. We will get one, but we want to do it in a unique way. All right? It will come. So that's just a little rundown of the site. We also do some South America stuff now. There's 7-day forecasts in here. We do have a live radar option that is back up and running. We're working on that. This is actually a pretty cool live radar feature. There's a lot of features on here that are pretty neat. As we go forward here into the winter, we'll be able to add features to this, okay? But there's a live radar feature here. Any of you guys that want live radar, I would recommend going and getting the Radar Scope app on your phone, on your tablet. It's $10 one-time fee, and it's called Radar Scope, and it is hands down the best. I don't make any money on that. It's not my product, but it's a product that we use that we like. Okay. So pivotal weather. Kirk, will you click on this while I point to them? I want to show you guys a couple things. So pivotal weather has a models section. So let's click on models. This is the free site you can go to if you guys want to look at this stuff. Right. So this is our domain, but it's all the same. Okay. What we want to do, let's say there's a storm and it's here right now, and we want to see how it evolves the next 15 hours, and you want to track it yourself. All right. You go to the HRRR model. All right. And there are different fields. They'll tell you temperature. Click on temperature. And then go to, let's say this is 13Z, go to hour 10. Okay, so this is probably your highs for the day. Takes us out to 23Z. All right, we've got temperatures in the mid-60s today. Okay, just tells you temperatures. All right, let's go to surface and precipitation. Okay, is that what we're on now?
That's where we're on.
Okay, and then we'll go to, let's say we want to look at what the radar may look like. Go to composite reflectivity. Okay, that'll give you an idea of radar. Obviously, it's not going to rain today. A little bit of rain up there in Wisconsin. Now, to look at those QTs we talked about, just click on the map. That's all you do. Just click your mouse right where you want to look. If it's over Indianapolis, you want to look in Indianapolis. Okay? Here's those fancy graphs we talked about. Look at the red and the green line and how far separated they are. What do you think this means in terms of a forecast?
Right here.
AKA sunshine. No clouds at all in this sounding whatsoever. All right. So, but here's your 0 line. See the 0? It goes up. Right through here. When wintertime comes around, you can use what we discussed today as a tool to see, all right, I'm in this area. Is there any warm air I got to deal with? All right. Does that make sense? Okay, go to, say we want to do the GFS first.
Michael,
Yes.
when you click on the map to go to that graph,
Uh-huh.
how specific, is that based on a specific weather site? Or how accurate is that if you pick out the middle of a cornfield in Monroe County, what's that gonna tell you?
So it's all based on the resolution of the model. So the HRRR is a 3-kilometer resolution.
Alright,
So it's out to the grid points. It's gonna pull the closest grid point,
okay,
if that makes sense.
yep,
So the GFS model, guys, is 12 or 11. I forget, 11 or 12. It's gonna pull from an 11-kilometer spacing. It's lower resolution. You're gonna have more voids in there. Not gonna get as much data. So go to the GFS. Are you on it?
Yeah.
Go, say you wanna look at rain the next 10 days. Go to hour 240.
Total
What's that?
rainfall.
Yeah, total rain, hour 240. Okay. This simply tells us how much rain the GFS says the next 10 days. That's it. Hover over it, right? If you want to look at soundings, I'd recommend after day 4 or 5, I really wouldn't look at them if I were you. Things are going to change so much, it's not even going to be worth looking at. Okay? But Pivotal Weather has a lot of great stuff. It's a free site. Go to Tropical Tidbits real quick, Kirk. I'll show you that site and then we'll wrap it up. Tropical Tidbits, if you go to forecast models, this is a free site. Go to Ensemble. This is the European Ensemble, EPS. And this is essentially what I've been talking about in the outlooks. What's this? Right, it's a ridge. This is a trough. Okay? So this is free. You can take this through the next 10 days. Take it through 10 days, Kirk. And it'll show us the pattern of what this model is saying. Now, does this mean because you have access to this site that you are now a forecaster and a meteorologist? No. But it gives you, if you're an enthusiast or a hobbyist and you like this kind of stuff, this is a fun site to go to, right? You can teach yourself as you go. Like I said, I know some guys. I know a guy named, I don't know if you guys know Michael Moss, but the guy is like a human computer that regurgitates statistics that you would never know were possible to know. Has no degrees. There are guys who have a lot of knowledge in this stuff that do not do it for profession. So you can master it if you want. Another great site here, though, obviously to go to. Go real quick up to stay there on the site, and then go up to analysis tools on the next one here. Yep, and then go to ocean analysis, and then go down to the 3.4 graph. Click on that graph. So this right here is the La Nina, or the ENSO graph. Anything below this solid line, okay, are temperatures in the equatorial Pacific, don't even know here, that are cool, all right? La Nina, below this minus 0.5. Look how cold we are right now. We are a -1. We've been there for a while. This is a La Nina atmosphere right now. So if this trend continues, we know where winter, I think, is going to go. So I want to open up for questions. Does anyone have, don't be afraid, there are no stupid questions in here. Anything you want to ask? Yes?
Do you ever look at the almanac?
I do. The Farmer's Almanac?
Yeah.
I do. And I think that the Farmer's Almanac is, I don't want to necessarily say it's useless, but it has ideas, but I'm not a big believer in it, personally. Now, they claim they have an 85% accuracy rate. I don't see how. They've done, last winter was supposed to be brutal cold, a lot of snow, and it was the polar opposite of that. We had some snow. It wasn't a snowless winter, but it was warm.
Have you seen what they're calling it for this year?
Is it like penetrating cold or something?
They're calling it numbing. Numbing.
Numbing cold.
Who uses the word numbing?
I don't know. That's why.
I mean,
Yeah.
not freezing, not below temperatures.
Right,
It's
but
like,
numbing.
we're in trouble.
Yeah, and so,
Use the word numbing.
and I think what's funny, is they use that wording to get people to talk about it, and here we are. We're talking about it. So yeah, it makes sense on what they do. This year I would have to say it's a potential. It could be a very cold winter, no doubt. So, Numbing? I don't know.
Well, for me-
Exactly, it's
for
exact,
me, it
Jimmy.
would be numbing.
Yes, exactly.
I guess we can wear shorts this winter for
Any other questions, guys? Good question. Yeah.
You see the PDO, it's been in this prolonged state, you see it going anywhere?
I think for winter, we look at somewhere around a neutral PDO. I think it could be slightly negative to slightly positive. The focus we want to keep on is that blob, that warm blob. Go to the sea surface temperature anomalies curve. But I would stay focused on that blob, top right. And click on it. Alrighty. Well, anyways, so this right here, Micah, is,
Yeah.
it's obviously still there. So a lot of the seasonal models say we go back into a positive PDO. The trend the last couple months has been towards negative. So, but either way, that's not going anywhere. So that's going to be kind of, you could call it a saving grace if you wanted to. It's a good question. That's all you had a question too.
Yeah, do you ever go with like the old times such as the persimmon seeds and the woolly ones? Do you ever do anything with those?
I look at that stuff every year. I really do.
The persimmon seeds are saying spoons
Uh-huh.
this year.
Yeah, shoveling snow.
And the woolly worms are black.
Yeah. I've seen a few white woolly worms too, which mean blizzard. I've seen a few white ones.
I'll go for that.
Yeah. Yeah. Yeah.
For somebody who doesn't have a computer most of the time around them,
Uh-huh.
for one, is your site mobile friendly, and two, do you have any list of stuff you recommend to have on my phone to keep track of stuff?
Yeah. Yeah, let's hook up afterwards. I'll show you. Yep, but the site is mobile friendly. Yep, for sure. Yeah. I'm sorry, I thought you raised your hand. No. Okay. Any other questions? I will say that on the lore, it's called folklore. I will say that last winter the persimmon seeds had shovels or had spoons.
The woolly ones go in the shell.
Also,
What's that?
with a knife or two also.
Yeah.
With the sharp bitter.
Right. So last year probably didn't get it so much. Now, we did have last year, guys. We were close. We had a big snowstorm in February that missed us to the northwest. We could have had a 10, 12-inch snow out of that storm, and it went just literally into Lafayette, not Indy. Okay, so that one was a close one. Overall, I do think those, some of the other lore is a lot of foggy mornings. Count the number of dense fog days in August. Those are the number of big snows you'll get in the winter. If you see the spider webs coming out early, it's spinning up early. Anything lore-wise that would suggest cold and snow, I've seen all of it already. So I don't know. We'll see if it's, it's all. I love that stuff. It's fun to look at.
It's called folklore.
Folklore, Folklore. There's probably 100 different folklore.
I think I've seen some of the biggest spiders I've ever seen.
The spiders have been big.
They're trying to come
Huge
inside
this year.
Does that mean anything, how big the spiders are?
I don't know. Honestly.
There's some I don't even want to kill, I just want to look at it. I can't believe it's that.
No, I kill all of them. Any other questions, guys, for up here? While I'm up here?
Do you have any idea what go back to the winters that were kind of anomalous, the 2001, 2002 winter, do we have any idea why it was so much warmer than all the others that were in this same?
Essentially, the start of those seasons were very warm. So it was hard to knock out the anomalous warmth in the beginning. A lot of this stuff is backloaded. So we started warm. The last 5 Decembers, guys, let's be real, have all started warm. Last 5 years have all been blowtorch Decembers. That's been kind of a trend for a while. So to make the statement that December is cold and snowy this year is bold and risky. It's a risky statement. But a lot of that is early season warmth. It's hard to knock that out. Like right now for October, we're running about 6 degrees above normal. We were just discussing this yesterday. For us to become neutral this month, we would literally have to turn cold and run 2-3 degrees below normal the rest of the month just to go neutral, just to knock out that +6. Even though the perception is everybody thought that October was cold, doesn't matter. It was so warm in the beginning that statistically it's a wash. Does that make sense?
Yeah.
That's a good question.
On your prediction match, you give a confidence and a risk factor. Can you explain what the Hallows are
Yeah, will you pull those up real quick, Kirk? So the confidence and risk level, the confidence is essentially the higher I am on the bar of the confidence, all right? You can pull up just whatever you want. Pull up the winter, or did you already click on them?
Yeah,
That's all right.
it's loading.
So, see the confidence bar? The higher it is up, the more confidence our forecasts have. Okay? The lower it is, the less confident we are. Show them the week 2 temperature. I'll show you how unconfident I am in week 2. Okay? So I've got the confidence down, less than half. I'm 40% confident in week 2. I don't know what's going to happen next week, by the way. I mean, there's a front there. There's signals there could be a big cool shock. There's also signals it could stay warm.
You have a negative nothing there?
Basically, this means you don't see any blue on the map, no reason to discuss it. So if the risk percentage is higher, it means the higher the percentage, the higher the risk in the forecast. Which means if I have a percentage at 70% risk, there's a 70% chance that something is going to go wrong with the forecast. Okay? So it allows you to evaluate our thinking as where we're at with everything.
How do confidence and risk play off each other? Because I think I'm hearing roughly the same thing.
You are. It's essentially we're trying to make sure we get our point clear. We just want to make sure you know that if you see a 70 and a 60 and something that's below, you know that something may go wrong, right? So, good questions. Any other questions, guys? Yes.
Are you doing a seminar in the spring for severe weather?
I probably will this year. I'll probably do it this year. What we may start doing is 4 seminars a year to do each season. They'll be free to attend. And we'll just, we'll knock out what we think as far as things go. Okay, that's a good question. Anything else, guys? All right, so, yes.
You've been talking about the European model for a long time. Do you still see that as being most accurate in the future? Like how the technology is going? Is there any newcomers coming into it? Is there anything to change coming up?
No. I still believe that it is overall, it is the best. Now, there are some models, guys, in the short term that have a lot of use. But we just had this discussion, our team just had this discussion this week, is sometimes why do we even look at the other models? Honestly. Why even exercise what they're saying, knowing their track record? The GFS had Hurricane Matthew going into the Northeast for like 9 straight days. And then all of a sudden you woke up and it wasn't there no more. The European never had it going into the Northeast. I don't think. So, the European is light years ahead. To pay to have access to all what the European does is $250,000 a year. It's very expensive. It's just hands down the best, So I don't see anything really up and coming as far as models that could compete with it. The Canadians have made big strides. The Canadian model is probably the second best. Hopefully that answers your question. So, good question. Anything else, guys? Anything else popping up? Anything at all? All right. Well, hey, I really appreciate you guys coming. Please take donuts. Okay? Take them with you out here. I mean, if you literally want like a half of a box. Okay? If you guys have questions, we'll be here. So.
Did you say we can see your office?
Yeah, if anyone wants to see the office, yeah.
And if you're not signed up as a subscriber,
Yep.
May I take this for one of my friends? May I take this for one of
Oh, yeah, absolutely. Yeah, no problem. Let me turn this around. Hi, thanks for watching, guys. We have a lot of viewers on here. It's actually quite impressive. We'll post this onto the YouTube. There'll be a link on YouTube where you can watch these or watch this, and I'll also email it out to everyone for the link. So thanks for watching, guys, and we'll talk to you soon. Thank you, Ed. 23,000 views. Wow, that's incredible. Thanks for watching. Does anyone have any questions on this before I sign off of this? Let me turn this. Any questions on here before I get going? Awesome. Guys, hey, have a great week.